Hello friends, welcome to lesson 3 of geometry. Today we're going to be taking a look at angles. A lot of this stuff probably seems like common sense, and that's fine. What we're doing though is we're going to define everything really carefully, really clearly, because we're going to be using everything logically to then build up the rest of geometry. So let us begin. Some of you may be named Ray, which is great for you. Ray is also a kind of figure in geometry. So you're welcome, I guess. And so array is we can add this to our knowledge of what we know in terms of right, we have lines that go on forever in both sides, segments that are limited on both sides. Array is stops on one side and then goes on forever in the other direction. So for example, here we have ray PQ. The way we name array is we put the endpoint first, and then we follow it with any other point on the line. And then we put a little ray sign above it. The order of the points matters. Ray PQ is different from ray QP. Ray QP would be something like this, what I'm drawing in blue right now. Okay, different thing. Opposite rays are two rays that have the same endpoint. So for example, ray YX, so that's this ray starting here and going that way, right? Ray YX and ray YZ, those are opposite rays. Same endpoint, and they go in opposite directions. If we put two rays together with the same endpoint, then we create an angle. So for example, here's an angle, and we have three different ways of naming this angle. You can name an angle just by a number that's in the middle. So for example, you could call this angle 1. And we draw a little symbol there. It looks kind of like a bent over L, or it looks like a less than symbol, except that the bottom is supposed to be flat and the top is at an angle. So we can call this angle 1. If we don't have a number in there, you can call it by the vertex, right? So this is the vertex of the angle, the place where the two rays meet, the endpoint of the two rays. So you call this angle S. You could also call it, because sometimes you might have a bunch of angles that have the same vertex, and so it'd be confusing to call it angle S, and then you say, which one are we talking about? So the most thorough way to name it is going to be to use three letters, and we would call this angle R, S, T. The vertex goes in the middle. So it's kind of like we're going in order, right? R, S, T. It's the angle that's mapped out by following those 3 points. So that's how we name angles. Uh, we can also consider the interior and the exterior of angles, right? If an angle is creating kind of like a mouth, depending on how big it is or small it is, right? Then there's the interior of the angle. That's just all the space between the two rays. And then the exterior of the angle is all the space outside of that. That's not cut off by the angle. And remember that the rays go on forever in both directions. So it's an entire infinite space that's cut out by that angle. It's a little crazy to think about. Now, the way that we measure angles, we use a tool called a protractor. A protractor, you'll notice it's got some numbers all around it, right? It starts at 0 here, and then this one goes around all the way to 180 over here on the opposite side, and then back all the way to 360. This is 350, so the next one would be 360. So we call this 360 degrees. All we're doing is we're taking a circle and dividing it into 360 even parts. And so each part is a degree. Here's another one, very common to see this kind. And here it's, you'll notice we've got 0 to 180 on the inside. And then on the outside, this one goes from 180 all the way to 0. This is in case you wanted to measure from one side or the other. And the way you would use this, you'd measure up, you'd put the vertex here in the middle, and then you'd line up one of the rays with 0, and then you're going to look to see where the other side lands. And so this brings us to the protractor postulate, which basically tells us that we can measure angles. Okay, all this is simply to say, right? I wrote all this stuff out here. You have opposite rays, yx and yz, and then every ray that can have y as an endpoint. And what we do is we just pair up the numbers, right? So if we imagine another ray starting at y, and then this ray can go anywhere here, and wherever it is, wherever it's paired up, then that would be the measure of that angle, right? Or if I have two rays, the way that I can measure this angle is I just take the difference between the two, the numbers that have been paired up with these rays. So for example, this one is 50 and this one's 90. So 50 minus 90 is negative 40. Take the absolute value of that and it just gives you 40, right? So 40 is the degree of this angle. The measure of this angle is 40 degrees. Or you can even do it, right? You could use the outside. It should make no difference. 130 minus 90 is 40. That works also. Okay, and so that's how we do that. The way that we note, the way that we write the measure of an angle is you just put an M in front, right? The measure of angle, uh, so let's give this a name here. We'll call this R and S over here. So the measure of angle R, Y, S, that's not an S, equals 40 degrees. Okay. So just like when we had lines, we had the line above the segment, right? Like segment AB, something like we had the line above it, we're referring to the figure, and then no line just meant the length of that segment. Here, the way that we get the measure of an angle is we put a little M in front. So we read that the measure of angle RYS. Okay. Um, and so, for example, here's another example. What is the measure of this angle? What's the measure of angle CAB? Okay, well, the B is lined up with a 0, so this is nice and easy because any number, we just subtract 0 and we get this. So 0, 70 minus 0 is 70. You can even use the 180 and the 110 if you want. Makes it a little bit harder, but it should work just to show, right? 180 minus 110 is 70. So we would write here that the measure of angle CAB equals 70 degrees. We can classify angles based on their measurement as well. 90 degrees is kind of an important angle. And so anything less than 90 degrees is an acute angle. Okay, so acute, these are angles where the measure of the angle is less than 90 degrees. A right angle, that's an angle where the measure of the angle equals 180 degrees, equals 90 degrees. Okay, and we often put a little square in the corner here to show that it's a right angle. It's a square angle. So if you see this, it looks like a little box stuffed into the angle there. That means it's a 90-degree angle. An obtuse angle is one where the measure of the angle is greater than 90 degrees. And then a straight angle is one where you have opposite rays, right? And so here the measure of the angle is 180 degrees. Okay, so that's how we classify angles. Again, a lot of this stuff you probably already know, but we're just defining it really carefully at the beginning as we build up from this. The angle addition postulate tells us that we can add the measure of two angles. And so what we're saying here is that if we have a point that's on the interior of some angle, so here's angle EHG, F is on the interior of that. If I make a ray out of HF, then now I have three angles. I have EHF, FHG, and EHG. And all I'm saying is that the measure of this angle plus the measure of this angle is the measure of the whole thing. Again, seems very obvious, but again, we state it clearly anyway. And the way we write this is the measure of angle EHF plus the measure of angle FHG equals the measure of angle EHG. That's the angle addition postulate. It's an assumption that we make, and we're going to build off of that in the future. Now, one more concept to cover, an angle bisector. So a bisector is something that divides something else in half. Okay, so an angle bisector is a ray that divides another angle into two congruent angles. There's that word congruent. Remember that? Same shape, same size. That's what that means. And so here, this ray ray PN. Okay, so I can write this. Ray PN, ray PN bisects angle MPQ. And so I can write this also, that angle MPN is congruent to angle NPQ. The way that I note this is I put little arc marks, like little arcs in there. So these are like the tick marks that we put on line segments to show that they are congruent, except here it's these little arc marks, almost like little pieces of a circle. And that's to indicate that this angle is congruent to this angle. These little arc marks, the tick marks, they all come in really handy when you're reading about a problem, when you're looking at something and you're finding out that things are congruent. You just put those marks in there, and then that's a visual signal to you to remember, oh, these things are congruent. And that helps in all kinds of situations, lots of application. And so that is it. That is your introductory lesson to angles. Thanks for watching. Don't forget to like and subscribe.